me. So without further ado, I usually start with this presentation with this quote. This quote says, 95% of the words are spent extolling the benefits of modularity, and very little, if anything, is said about how to achieve it. Now, I can really relate to these words because about 6 or 7 years ago, I've been working for a company called International. And one day, we decided to jump on this microservices bandwagon. So, of course, we read Sam Newman's book. We got inspired by success stories of Netflix, Google, eBay, Amazon, and other microservices heroes, and we decided to give this architectural style a try. About 3 months later, we found ourselves in such a huge mess. Now, what happened was we concentrated our efforts on, the cool, interesting things, cool technological things, but we didn't pay due attention to the more fundamental stuff, modularity, and how can we achieve it, just as this quote says. So we invested in serverless frameworks, modern messaging platforms, but we didn't think over how to properly decompose a system into microservices, like where to draw those boundaries between the services, how to decide whether some functionality should go to one service or another one. Instead, we said, hey, there is this micro thing in the name microservices, so they probably should be small. So we naively approached microservices, thinking that the smaller the service, the better. And this way of thinking led us straight into the chains of a distributed monolith. Over the next few years, we tried to right our wrongs. Instead of going for those tiny services, we decided to try some different ways to decompose a system into services. And in this presentation, I want to share with you what we had learned along the way during those years. That's our agenda. I will describe those decomposition strategies that we tried. Next, we'll see how they apply in the microservices world. And we'll go over some design heuristics for optimizing microservices-based architectures that we ended up using at Internals. Now, since I'm going to use Internals for all the examples here, I'd like to take a minute and briefly introduce you to the business domain of that company. So say you're producing a product or a service. Internals allowed you to outsource all of your marketing-related chores. You would get the best marketing strategy for a product. Its copywriters and graphic designers would produce tons of creative materials, such as banners and landing pages that would be used to run campaigns to promote our customers' products. Now, all the leads generated by those campaigns were handled by Internals' own sales agents who made the calls and closed some sales. Now, most importantly, this whole process provided many opportunities for optimization. That's exactly what the analysis department was in charge of. They analyzed all this data to make sure that both Internals and its customers all are getting the biggest bang for the buck. That's the business domain of that company. Now, Internals doesn't exist anymore, which means I can say whatever I want. And with that, let's see the different ways we try to decompose that huge business domain into modular components. And the first one is bounded context. Now, I want to ask you, who here is familiar with the domain-driven design methodology? Can you write a plus in the chat window? Cool, I see some pluses.
And I guess you just mean familiar at a high level, not intimately familiar with all the pieces. Yeah. Okay, good.
Okay, so we have some pluses. Anyway, so domain-driven design methodology, as you can see, this book is quite big. I cannot introduce all of it in merely 40 minutes. So so what I'm going to do, I'm going to introduce the different elements from that methodology, which are relevant to our discussion here today. So the cornerstone practice of domain-driven design is called the ubiquitous language. So the idea is to build a worthy model of the business domain in code. In other words, to implement its business logic, we have to understand the way the domain experts, people from the business domain, are thinking about that business logic. And the most effective way to do it is to speak with them and to do it in their own language, the language of the business, which means if I'm a software engineer and I'm talking to somebody from, I don't know, the marketing department, I won't tell them that, hey, we have this table and the pessimistic concurrency check is failing because some race condition. They'll look at me and say, what? Instead, when we are interacting with domain experts, we want to speak the language of the business. So for example, I don't know, hey, we have this advertising campaign which runs for X amount of days, and now it's in collision with another one which promotes the same product. That's the language of the business. The moment we can speak with domain experts in their own language, we'll have a much deeper insight into how that business domain works, and we will be much more successful at implementing its business logic in code. Now, one of the requirements for the ubiquitous language is that each term in that language has to have one and only one meaning. Why is that? Well, because, you know, as people, we can extrapolate the meaning of a term according to its context. However, when we are implementing this business logic in code, it's much harder. Code doesn't deal well with ambiguity. So we want to make sure that each term in that ubiquitous language has only one meaning. However, that's not easy. Domain experts, they're humans, and their behavior can be complex and unpredictable. Some of them can have different mental models for the same business concepts, and others might use the same terms to describe completely different concepts. For example, in Khononov, we had campaign managers and sales agents, and for them, the term lead meant very different things. For a campaign manager, a lead was a mere event that somebody has shown interest in a product and submitted their contact details. For a sales agent, on the other hand, a lead was a much more complex entity. It had lots of data associated with it, and it had a very rich and complex behavior. In such cases of conflicting models, domain-driven design calls for splitting the ubiquitous language and explicitly defining the context in which each smaller language can be applied, its bounded context. Again, in our case, we had leads in two bounded contexts, marketing and sales. Each bounded context defined one and only one model of the lead that was correct in its boundaries. And when we just started, we used these boundaries to decompose our initial monolith. Each bounded context became a separate service, marketing service and sales service. So that was our first strategy, aligning service boundaries with bounded context. However, these services represented pretty wide business areas. You know, as long as there are no inconsistencies in the models, this bounded context can span multiple business subdomains. For example, in marketing, we had creative catalog for organizing creatives, contracts for managing relations with publishers, and campaign management for running the actual advertising campaigns. In the sales context, we had our CRM system, our solution for managing desks, commissions, and others. And we later used these business subdomains to serve as the physical boundaries of services. How do you identify a business subdomain? Well, usually subdomains, they correlate with departments you have in your organization, with its organization units. Also, from a more technical perspective, we can say that a subdomain is a set of coherent use cases. those requirements that operate on the same set of data and have interrelated business rules and interrelated business logic. So we divided our initial two bounded contexts into smaller ones, smaller services, each representing one business subdomain. So we ended up with services for managing campaigns, creatives, desks, and etc. And actually, this approach is quite common. In the DDD community, many are calling for having a one-to-one relationship between subdomains and microservices. Also, if you look at that microservices book by Sam Newman, I think it was the first book on this topic, he spoke about that. You should identify those subdomains, and they're probably gonna be your microservices boundaries. However, when we embarked on that microservices adventure, we strived for even smaller services. So we dug deeper into the business subdomains and extracted their entities and processes into their own microservices. For example, in our campaign management subdomain, we had business entities such as campaign, funnel, target market, and others. And we used these entities as boundaries for designing services. And that was our third strategy, having each microservice represent one business entity or process. And as I told you in the introduction, initially this approach failed more than miserably for us. However, it did work later in our future projects. So to quickly sum it up, these are the three strategies that we had used. We started with an enormous monolithic bounded context. Then we split it into real bounded context to protect the consistency of the models of the ubiquitous language. And then we tried decomposing them into smaller services, having a service per subdomain. And in the future, we tried dedicating a service for each business entity. So the question is, which of these three strategies produces those coveted microservices? And actually, I want to ask you, what do you think? We have three options here. What do you think is the best solution for designing microservices boundaries? Please write me your opinion here in the chat window. So somebody just left. At least subdomains, okay? Come on, people, wake up. Yep, around services. Boundaries for microservices, what do you think? How wide or small should they be? Okay, so we have two people that say subdomains and one for business entities and processes, and a combination of all. Yeah, it depends. Great answer. Well, let's see. So we have those three suspects. Let's see whether bounded context make good microservices. So I've shown you an example of conflicting models from our company, LEAD. Same term that meant totally different things in marketing and sales contexts. And to tackle that complexity in the model, we split the implementation into two distinct models, each relevant only its own bounded context, which meant if we were to cross that boundary, we would end up with inconsistent models and unexpected behaviors. But are bounded context actually the smallest boundaries possible? So let's see. Naturally, bounded contexts contain multiple related subdomains. You can move those subdomains around. You can decompose them further into smaller bounded contexts. But as long as you don't cross the boundary of inconsistent models, according to domain-driven design, all these designs are equally valid bounded contexts. There are no conflicts in them. Each term has only one meaning, and all the models are consistent. Therefore, bounded contexts rather help us to identify boundaries of the biggest valid monolith. And the word valid is the key here. That's not a bad thing. Such a monolith won't necessarily lead you straight to a big ball of mud. No, it's a viable model that you can work with. But that idea doesn't quite fit the notion of microservices. For microservices, we want smaller boundaries. Another way to put it is, each microservice is a bounded context, but not each bounded context is a microservice. So for microservices, we have to look elsewhere. And here we are left with two options, subdomains and business entities. To see which one is the better candidate to play the role of a microservice, let's take a step back and define what exactly are those services and microservices that we are talking about. So first of all, a service is a unit of functionality exposed to the world. Or a bit more elaborately, according to the team behind SOA, a service is a mechanism to enable access to one or more capabilities where the access is provided using a prescribed interface. Now, this prescribed interface is very important. Randy Schaub, one of the pioneers of the microservices hype, he defines these prescribed interfaces as any mechanism for getting data in or out of a service. It can be synchronous, such as a plain request-response model, or it can be a bulk ETL operation. It can also be asynchronous operation by producing or consuming events. But overall, synchronous or asynchronous, those are just mechanisms for getting data in or out of a service. It's interface. Randy Schaub also calls the interface as the service's front door. I really love this analogy, and we're going to get back to it pretty soon. So that takes us straight to the definition of a microservice. A microservice is a service with a micro interface. As simple as that. Micro front door. There were some people tried to evaluate microservices boundaries by counting the number of lines of code in that service, or by counting the number of pizzas needed to feed the team working on a microservice. But I would say that these definitions are a bit fuzzy. I prefer this one. A microservice is a service with a micro interface, micro public interface. And the reason behind this is pretty straightforward. Having less connection points between these services, first, it reduces coupling between them, it limits their reasons for change, it makes it easier to understand each service in particular, and to understand the whole system in general. It also provides better fault isolation and makes services more autonomous for development, management, and scale. Also, we all know that microservices should own their databases. No other microservice should be able to access another microservice's database directly, but only through its public interface. Why that? Well, because if a database is exposed outside, it becomes an enormous public interface. How many different SQL queries can you execute on a relational database? I guess infinity is a pretty safe estimate here. But there is a caveat in this reasoning. Having a micro public interface might sound pretty simple, right? I would say deceptively simple. Let's limit those public interfaces to one method only, because you cannot go any further than that, and those will be your perfect microservices. Well, not really. Let's see what is going to happen if you'll do just that. Let's say we have this backlog service with 8 public methods. And we want to apply this naive decomposition here. Each service will expose only one public method. But since those are well-behaved microservices, each of them will have its own database, and no other service will be allowed to access it. But they still have to work together somehow. They have to synchronize the changes that each service is applying. And for that, they have to expose additional public interfaces, this time for integration purposes. So when visualized, those integration-related data flows look like this mess right here. So paraphrasing Randy Sharp's metaphor, well, we definitely minimized the front door, but due to the system's business requirements, in addition to the front door, we created this huge staff-only entrance, the one which is used for integrations with other services. Therefore, the threshold upon which a system can be decomposed into microservices is defined by the use cases of the whole system, and not by some rule of thumb like number of lines of code or the number of pizzas you're ordering. This is a way to represent this notion visually. Once we decompose a monolith into modular microservices, the cost of introducing a change goes down. But if you continue decomposing past that threshold, the services interfaces will grow back up, this time for integration needs. As a result, the cost of introducing a change will also go back up, and you will end up with the dreaded distributed monolith. That's another way to represent this notion visually. If you have everything in one monolithic service, we get a big ball of mud. If we decompose it into proper bounded context, then the average size of the service goes down. It gets even smaller for microservices, but if you keep decomposing further, you will get back the big ball of mud. And it's going to be a distributed one in this case. So these are subdomains, nor business entities can be treated as microservices in all cases. Sometimes a subdomain's boundary can produce microinterface, and there will be business entities and processes that could be decomposed into microservices without introducing additional coupling. It all depends on the system that you are building. And if we look at the bigger picture, we can see that microservices aren't really about what happens inside of a single service. Microservices are about the interactions and couplings between the system's components, its services. To put it another way, what happens inside of a service is local complexity, and what we are dealing with here is global complexity. And here I actually want to quote Glenford Myers again. He says, global complexity is the complexity of the overall structure of a program or system. That is the degree of association or interdependence among the major pieces of a program. Now, this quote might sound like it was taken from some new book on microservices, right? Well, not really. Actually, it was taken from this book right here. It's called Composite Structure Design. And as you can see, its cover looks pretty outdated. And the thing is, this book dates all the way back to 1978. Yep, it's 42 years old. And instead of microservices, this book talks about procedural code. But still, the same design principles apply in our context, building distributed microservices-based systems. And there's nothing surprising here. The ideas behind microservices are nothing new. Those are just age-old design principles. They were tested out in different paradigms and even in other industries. For example, cross-functional teams are all the rage now, right? Well, what is a cross-functional team? A cross-functional team is a team that minimizes the communication outside the boundary of the team and maximizes the communication inside of the team. Same idea, same principles as microservices. Also, here is an example of what Tim Berners-Lee says in his Principles of Design article. He says, when you design a system and the features can be broken into loosely bound groups of relatively closely bound features, then that division is good design. This is just good engineering. Maximizing connections inside of a service, increasing its cohesion, and minimizing connections outside, reducing coupling. It is just good engineering. Therefore, microservices are nothing but services combined with good engineering practices. In the same post, Tim addresses the fact that components make up systems, and those systems are components themselves in other larger systems. And we always have to keep that in mind when designing microservices. Because, you know, we are talking about those microservices boundaries right now. But if you take a step back and look at software design, you will see that most of the design decisions that we are making are about boundaries. You know, we have boundaries of classes, objects, and modules, namespaces. Those are so-called logical boundaries. And then we have the boundaries of services, the physical boundaries. The thing is that design principles that drive those decisions for all those boundaries are exactly the same. So when we are designing a namespace or a module inside of a monolith, if we use the same reasoning for designing, for making those boundaries effective, we can later refactor them into physical boundaries, which means extract a microservice out of it. It will be much easier. One more quote, this one from 1972. Barbara Liskov published a paper called A Design Methodology for Reliable Software Systems. In this paper, she discusses how to achieve good modularity. And again, she likens good modularity to minimizing the connections between modules. So I want to reiterate, a microservice is a service with a micro interface, micro front door. The correct size of the interface is not an absolute value. It's relative. It's defined by the system that the microservice is a part of, its business requirements, its business domain. And that brings us to good news, bad news. Bad news, there is no easy way to evaluate a system's design. You know, in the past, we had a model for evaluating levels of coupling of procedural code, described in that book that I've shown you. We had such a model for object-oriented code as well. Miller Page Jones introduced the notion of connaissance. But we're not there yet for services. We still don't have, you know, an algorithm that we could fit a system design and would get an objective score, how good or bad that design is. We are not there yet. But the good news, we have some design heuristics that can help us to streamline the process of decomposing systems into microservices. I want to show you 10 heuristics that I found most useful back at the days at Internodes. So first, always decompose your systems to bounded contexts. If you notice terms that mean different things to different people, define strict bounded context and decompose the system accordingly. Do not implement conflicting models in the same service. Otherwise, there will be balls of mud in your future. Second, do not decompose bounded context further unless you've got a good reason to do so. And that's Martin Fowler's first law of distributed object design. Don't. Because, you know, we can hear left and right about the benefits of microservices, But as each distributed system, they do come with a set of challenges and hurdles. Microservices have both pros and cons, just like wider boundaries do. And it's crucial to verify where you are actually dealing with a monolith or not. Actually, a better term here would be whether you are dealing with a big ball of mud or not. Because a big ball of mud is not a type of a project or a code base which is longer than X lines of code. No, it's an architecture that undermines business goals, such as delivery of functional or non-functional requirements. If that's not the case, wide service boundaries do have their advantages. They're more flexible and easier to refactor. So before you decompose further, make sure you really need those benefits of microservices, and you're down with the additional risks and challenges that this architectural approach introduces. Again, if you're one team, you're working on a greenfield project, maybe you can stay in the boundaries of a bounded context and decompose further maybe later when you will really need that. Now, let's say you've evaluated the options and you came to the conclusion that, well, you do need to decompose further. You do need microservices to support delivery of some functional or non-functional requirements. So after bounded context, the next level is the level of business subdomains. And domain-driven design is an indispensable tool here. So remember we spoke in the beginning about business subdomains. The thing is, not all of them are made the same. Actually, there are three types of business subdomains: core, supporting, and generic. And this categorization can be extremely useful for designing microservices. The first type, generic subdomains, are all the things that all companies are doing in the same way. For example, in Khononov, we had identity and access, a telephony system, and billing. All these subdomains are complex and boring. Not only that they're complex and boring, but these are already solved problems. We have off-the-shelf solutions that we can just buy or maybe adopt from open source. We don't need to invest time and effort here into implementing our own encryption algorithm or a monetary transaction tracking system. It will be cheaper and safer to pick up an existing implementation and use it. And it makes a lot of sense to treat these third-party solutions as separate services. And of course, keep them in the boundaries of their subdomains. In addition, it may be very beneficial to abstract the model and implementation details of those third-party solutions by implementing a thin anti-corruption layer that will be used as a proxy between the consumer and the adopted product. Not only that this ACL anti-corruption layer exposes a more convenient model to work with, but it also limits the public interface to the actual system's needs, which will make it a well-behaved microservice. The opposite of generic are core subdomains. And here the company is inventing something new or optimizes some existing practices to gain competitive advantage. Or in other words, this is how the company makes money. So for Khononov, campaign management, the CRM systems, and the tailor-made system for assigning sales agents commissions all were our core subdomains. Inherently, core subdomains have complex business logic, but contrary to generic subdomains, here we cannot and we do not want to use an existing implementation. We want to invent our own solution here. But inventing something new is not easy, especially complex business models. Lots of different implementations have to be tried out in order to find the one that maximizes the company's profits. And here, by the way, I'm talking about both sides, the problem domain, the business itself. For core subdomains, in the beginning, they're not sure how they're going to implement them. So the requirements of core subdomains are going to change, and they're going to change often. And same goes for our side, for the technical side. From the implementation perspective, these are not trivial problems to solve in most cases. So more often than not, you will have to refactor your implementation. So this logic is complex, it's going to change, and it's going to change often. Therefore, do not rush to decompose core subdomains further. Stay in the boundaries of the subdomain. If you do need to decompose further, wait till you gain more domain knowledge and there are less changes in the business logic. Because again, the last thing you wanna do is to find yourself making changes across bad boundaries because you decompose that subdomain prematurely. That's going to be very painful. Instead, don't rush with core subdomains. Stay in that boundary, in the wider boundary. Wait till you gain more knowledge about the business domain. Wait till there are less changes in the requirements, and only after that, if needed, decompose further into smaller microservices. And by the way, in the introduction, I told you about our experience, our first experience with microservices, how we ended up with a distributed big ball of mud. Well, that's what we did. We decomposed a core subdomain into tiny microservices. That's why we ended up with a solution that didn't achieve its business goals. I will say it that way. Finally, supporting subdomains. As generic subdomains, they do not provide any competitive advantage for the company, but they are needed to support the company's core business. For example, to publish advertising campaigns, we had to manage our creatives, and we had to manage our contract with publishers. On the sales, in the sales context, to have a CRM system, we had to manage our sales desks around the globe. Now, there is nothing complex in these domains. We didn't have to invent anything novel and smart here. Those are just simple CRUD interfaces for managing records. Also, contrary to the core subdomains, they change rarely. The business is not really interested in optimizing them or changing them often. They do not provide any additional profits. Therefore, we found it safe to decompose the supporting subdomains further, even at the earlier stages of a project. That's where that approach of having those tiny services, each representing a distinct business entity or process, did work for us, for supporting subdomains. So those were the three heuristics related to the different subdomains, types of subdomains. Now let's look at decomposition into microservices from a different angle. Let's say we have two methods that operate on the same data. We can decide whether they belong to one service or can be decomposed into two services by evaluating their consistency requirements. If they require concurrency control, which means only one of these methods can be executed in parallel, then both belong to one service and cannot be decomposed. If one service should always read the last write of the second one, then they can be decomposed into two services, but integrated through a synchronous call. Lastly, if they can settle for eventual consistency, then they can be decomposed and integrated asynchronously through events. Now, of course, these are not hard rules. Those are just heuristics for what is possible. There is no point in implementing asynchronous communication if a simple synchronous call can just do the job for you. And speaking of asynchronous communication, exchanging events became the default way of integrating microservices. Those events, just like methods, are parts of services' public interfaces. So let's see some heuristics for optimizing events or event schema. So often services can emit quite a few types of events. It is especially true in event source systems. But do we really need to expose dozens and even hundreds of different types of events? Well, in many cases, the events can be categorized into private events, which are the implementation details of a service, and public events, which are intended to be the service's public interface. Thus, exposing only public events minimizes the service's front door. Another way to minimize event-based public interfaces is to compress them. Let's say you have a service emitting 3 types of events: email changed, phone number changed, and address changed. Do you really need to expose such fine-grained events? Well, think about combining them into contact details changed event. And of course, if you need to, you can keep those smaller events as private implementation details in the service, but project the wider event and expose it as a part of the service's public interface. Another way to minimize the external footprint of the event is to notice that not all events are made equal. Well, everyone uses the term event nowadays, but if you listen closely, you will notice that actually there are 2 types of events. When speaking about events in the DDD or event sourcing communities, people imply domain events. A domain event is a notification that something interesting has happened in the business domain. For example, new lead was received, lead was converted, or campaign started. But if you listen to people outside of those communities, for example, Randy Schaub, you will see that by events, they mean something else. For Randy Schaub, and I quote, an event is a notification that some state has changed. So these events are only describing the actual change in a state without any relation to the business context. Now, it might sound limiting, but it makes lots of sense for integration purposes. You're going to have domain events inside of a service, but expose outside only state-changing events, thus keeping the domain knowledge inside of the service and minimizing its external interface. And if you are exposing events as the service's public interface, make sure that they are explicit. For example, here is a service emitting the agent assigned to lead events. The meaning of this event is implicit. What does it mean if we receive 3 such events, one after another? Does it mean that 3 agents are assigned, or should the last event override the previous ones? That creates an implicit coupling between the service and its clients. The clients have to make assumptions about the business domain and how it was designed in the code. And this design can be improved greatly, for example, by introducing an intermediate event, stating that the previous agent was unassigned, or have an event type, one event type, but call it assigned agent changed. Both options are much more clear, and the clients won't need to make any assumptions and guesses about the meaning. Now, the last 2 heuristics are for the after-the-fact scenario. So let's say you have 2 services, and you sense a design smell. Each time one of them changes, the second service has to change as well. Typically, that indicates that the services are tightly coupled. Therefore, evaluate those reasons for change, and if you find commonalities, check whether you can loosen the coupling between the services. If not, if you cannot loosen that coupling, consider merging them into a single service, because what changes together has to go together. And here I want to mention another pretty old paper on software design. It's called "On the Criteria to be Used in Decomposing Systems into Modules." And David Pernas talks about here exactly about this idea, looks for reasons for change and use those reasons for designing your module boundaries. And for the final heuristic, let's go back to the public door metaphor. If a service's public interface is wide and contains many business-wise unrelated methods, then it can be split apart into smaller services. Also, always compare the methods which are used for implementing business requirements and methods implemented for integration purposes. If more methods were added for the sake of integration, it might be a sign of a distributed monolith. Consider re-evaluating the service's boundaries. In such a case, again, the system's design might be simplified greatly by merging some of those tightly coupled services together into a single service. So those were the 10 design heuristics that I wanted to show you. Now, let's do a quick recap. So a service is a unit of functionality exposed to the world. It's public interface. It's public front door. A microservice is just a service with a micro interface. The size of the microservice's boundary cannot be measured in pieces or lines of code. It depends on the use cases of the overarching system. Our goal is to reduce the global complexity of the whole system, the interconnectedness of its components, and not just reduce the local complexity of each service individually. We've seen that the minimal decomposition level is bounded context. Fowler's first law, don't decompose if you don't need to. We saw the different types of business subdomains and how they can help us in designing service boundaries. Core subdomains stay in the wider boundaries as long as possible. Generic subdomains stay in the boundary of a subdomain and just adopt an existing solution. Supplying subdomains, if needed, they can be decomposed early. Evaluating consistency requirements can help us to decide if two methods belong to the same service or can be split across multiple services. And it also can help us to decide how these services should communicate with each other, synchronously or asynchronously. Exposing tons of different event types couples the service to its clients. Consider having private events as implementation details, but expose a more restrained set of public events. A way of minimizing the number of out-facing events is to compress the data from multiple private events into a wider public event. Also, remember that events come in two flavors: domain events and state changed events. Use both types when you need them. Make sure that your events are self-describing and explicit. And if you have multiple services that change in the same rate, look for ways to reduce coupling between those services. If it can be reduced, consider merging them into a single service. And finally, evaluate your services' front doors, their public interfaces. If they are too wide, consider decomposing the service into smaller ones, or if there are much more integration-related public methods, then consider reassessing the boundaries to simplify the system's design. And I want to finish by showing this diagram again because I really like it. So if you stay in one huge monolithic solution, you will get a big ball of mud. If you decompose to bounded context, you get a viable solution and viable boundaries that you can work with. You can decompose further into microservices, but you have to stop right there. The fatal mistake to do is to decompose further, and then you will get with a distributed big ball of mud. Now, if you ask me, I prefer an old-fashioned monolithic big ball of mud than a distributed one. That's the source code of this presentation. Everything that I've shown you here was composed from these books, papers, presentations, and of course my personal experience at Internovus. If you want to learn more about domain-driven design, not long ago I've written this book, What is Domain-Driven Design? It's available on O'Reilly's online learning platform. If you're a subscriber, you can get it for free. Another book, Domain-Driven Design, the First 15 Years. This one you can get for free at this address. And in this one, I wrote a chapter in which I share the whole story of implementing domain-driven design at Internovus, the different approaches we tried, and the results we got. That's my Twitter, my blog, and most of the stuff I spoke about today, I have blog posts about it as well. And last but not least, this link here, careers.doitinternational.com, if you want to work with me in our amazing company. That's the URL. And with